Hello everyone. So in this lecture we'll continue with the relational algebra. So in the previous lecture I explained about unary relational algebra operations, and in this we'll see the relational operations which are based on set theory. Okay, so based on set theory we have union, intersection and difference, and the last one is Cartesian product. So these four operations comes under relational algebra operations from set theory. Now union operation, it is a binary operation denoted by U, the letter U, and already you know what is mean by unary operation because it is the concept you are studying in set theory, right? The same thing applies here also. The result of union operation will give you the relation which includes all tuples that are either in relation R or in S or in both. Okay, so tuples which are there in either a relation S or in R or in both. And when you take the union, the duplicate tuples will be discarded. Okay, it will not list the duplicate tuples. Now, one important condition must be satisfied when you are taking the union or intersection or set difference, that is type compatibility. Okay, the two operand relations R and S must be type compatible. Now, what is mean by type compatibility? Type compatible means R and S must have same number of attributes. Okay, R and S must have same number of attributes. If you have 3 attributes in one relation, then in another relation also you must have 3 attributes. Now each pair of corresponding attributes must be type compatible. That means they must have the same domain for the corresponding attributes. Suppose you think you have 2 attributes in relation R, okay, attribute 1 and attribute 2, and in relation S also you have 2 attributes. Now if the attributes in relation R are of domain integer, one of the attribute is of integer type and another one is character type, then in the second relation, yes, the attributes must be of same type. That means one must be of integer, another must be of character type. Okay, so that is the second point. So each pair of corresponding attributes must be type compatible. Okay, they must have same or compatible domains. Now we'll see the example. To retrieve the social security numbers of all employees who either work in department 5 or directly supervise an employee who work in department 5. Now how we can obtain the result for this? You take one of the query which will fetch SSN of the employees working in the department 5 and another query which retrieves SSN of the supervisors. Okay, SSN of the supervisors who are supervising the employees in department 5. Okay, so query goes like this. First we'll take all the tuples which satisfy the condition department number equal to 5, and from this intermediate result we'll fetch SSN, okay, using the project operation. So result 1 contains SSN of employees working in department 5. Now the second part where in the department 5 underscore EMPS we have the tuples of employees working in department 5. From those tuples we will fetch the super SSN. Okay, so super SSN will give you the supervisors SSN who are supervising the employees in department 5. Okay, now we got the intermediate result of result 1 and result 2. Now what is the next step? We have to take the union. Okay, result 1 union result 2. We'll see the output of this. Result 1 is having 4 assistants, 4 different assistants, and result 2 will give you the super assistant who are supervising the employees in department 5. Now you take the union, then it will give you the required result. Okay, so when we take the union means the values assistants which are there in result 1 or result 2 and in both. So those will be appear in the union operation or result of the union operation. Now we'll see like formally how we can define the type compatibility. For all the operations like union, intersection and set difference, the operand relations must be type compatible. Now if I take R1 and R2 as two relations, and the attributes in R1 are A1, A2 and so on. In R2 we have B1, B2 and so on. Now both the relations, the operand relations must have same number of attributes. If R1 is having 10 attributes means R2 must also have 10 attributes, and the domains of corresponding attributes are type compatible. That means if we take domain of AI, it must be equal to domain of BI for all the attributes. Okay, and the resulting relation, in the resulting relation, the column header will appear same as the attributes which are there in the first operand relation. That means in R1, whatever name we have given for the attributes, so those name will appear in the resultant relation. Now the next is intersection. It is denoted by inverted U, and the output of this operation or the resulting relation will include all the tuples which are common in these two operand relations. Okay, like the tuples which are common in both the relations, those will appear in the resulting relation, and the attribute names will be same as the attribute names in the first operand relation. And the condition, the type compatibility condition must be satisfied. Okay, and the next operation is set difference. It is also called as minus or except, and it is denoted by minus symbol. Now what is the resulting relation here? The result of set difference will include all tuples that are in relation R but not in S. Okay, so whatever tuples we have in the first operand relation but which are not there in the second operand relation, so those tuples will be retrieved. Okay, and the attribute names in the result will be same as the attribute names in relation R. That means in the first operand relation. Again, both the relations must be type compatible. Now we'll see the example of all this: union, intersection and set difference. The operand relations are student and instructor. Here you can see these two relations are type compatible because both are having two attributes. So number of attributes are same. And if we see the domain, like first name, last name, and here F name and L name, so each corresponding attribute is having the compatible domain. Now when we take the union, so as per the definition, it says the tuples which are there either in student or in instructor or in both, so that will appear in the result, and the duplicate tuples will be eliminated. So here if we see the two relations, in these relations, the Susan and Ramesh, these are common, right? That's why only once it will appear, because to avoid the duplication, only once it will appear in the result. Okay, so you can see Susan, Ramesh, and then Johnny, Barbara, Amy, Jimmy, and Ernest. So these are from student, and in the instructor we have John, Ricardo, and Francis. Susan and Ramesh will not be displayed again to avoid the duplication. And then the next one is intersection. In the intersection, if it appears in both the relations, such tuples will be retrieved. So Susan and Ramesh are common, so that will appear in the resultant relation. And then the next third one, you're taking the difference, student minus instructor. Student minus instructor means which are there in the student but not in the instructor. So Susan and Ramesh are common. So the remaining Johnny, Barbara, Amy, Jimmy, and Ernest are not there in instructor. So those 5 tuples will be retrieved. And the last one, instructor minus student. So in the instructor minus student, Jimmy, Ricardo, and Francis. These 3 are there in instructor but not in student. So these 3 tuples will appear in the result of instructor minus student. So one thing you can notice here, if we take student minus instructor, it is not same as instructor minus student. Now both union and intersection are commutative operations. That means if I change the relations, then it will not affect the result. You will get the same result. R union S if I write, or if I take S union R, but the result will be same even in case of intersection. Okay, and we can have the number of relations, operands. Okay, we can apply this for n-ary operations like R union, S union T, then R union S first we can take, and then we can union it with relation T. Okay, so in that way it is associative. We can group in any order. But the minus operation, it is not commutative. That means if I take instructor minus student, it is not same as student minus instructor. Now the last one is Cartesian product, or it is also known as cross product, and it is denoted by X symbol or the cross symbol. Now if I take relation R with n number of attributes and relation S with m number of attributes, in the resultant relation you will get n plus m number of attributes. So what it does is it will take the combination of each tuple of R with S. Okay, so it combines tuples from 2 relations in a combinatorial fashion. So if we have n number of tuples in R and m number of tuples in S, then in the resultant you will get n into m number of tuples. Okay, that means for example, if you have 10 tuples in relation R and 8 tuples in relation S, in total you will get 10 into 8, so 80 tuples in the resultant relation. Okay, so those many tuples you will get in the result. And one more thing you have to notice here, that is the operand relations have not the operand relations do not have to be type compatible. Okay, so that restriction is not imposed on this Cartesian product. It can have any number of attributes. That means the number of attributes may not be same, and the domain is also not same. Okay, so you can have same number of attributes or may not. So the restriction is not imposed on Cartesian product. Now when we take the Cartesian product, we may get some meaningful result or some tuples may not have the meaning. That means actual purpose may not be uh, uh, given or produced using Cartesian product. Okay, so here if you take the example, the first statement or the first relational expression says you are retrieving all female employees. You are fetching female employees information, okay, by using select operation, and the condition is sex equal to F. So female employees information you will fetch. After this, on this intermediate result, you'll apply the project operation and you'll take only the F name, L name and SSN column. Okay. Then once you got the F name, L name and SSN of the female employees, now you'll take the cross product with dependent relation. Now what happens in the resultant of this cross product, you'll get all the combinations or every combination of female employees and the dependents, whether they're actually dependents of those employees or not, but it will take all the combinations. Okay, so that's why it will include some meaningless information. So all the tuples are not meaningful. Now how we can filter out only the meaningful tuples? So if we apply the select operation with the condition, then we can get the meaningful tuples. See here, after taking the cross product, now we'll put the condition SSN equal to employee SSN. What happens in this case? It will take or it will fetch, selects only the tuples which are matching with SSN and employee SSN. Okay, that means these are the dependents of the female employees. Only such tuples will be selected. And from this actual dependence, we will take F name, L name of the female employees and the names of their dependents. Okay, so using project operation, we will fetch only the name, first name and last name of the female employees and their dependents. Okay, so now in this case, each tuple will be having the meaning. That means the actual dependents of the female employees will be fetched.